Hello students, so in today's class let us complete exercise 1.6. Hope you have learnt all the important results which I stated in the previous class based on the cardinal number of a finite set. So if you know all those results, we can very well solve this exercise, and moreover this is a very easy exercise. I am going to give just the hint or the clue. You are going to solve the remaining problems, right? So if you see the first question, what is given in the first question? N of x, it's a direct question. If x and y are two sets such that n of x is equals to 17, n of y equals to 23, n of x union y is 38, they asked you to find n of x intersection y. So what is the relation between the two sets and its union and its intersection? We know n of x union y. It is not necessary it should be x, y, a, b. The result is same, right? So n of x union y is equals to n of x plus n of y minus n of x intersection y. So just to substitute the values there, n of x union y is 38, n of x is 17, n of y is 23 minus n of x intersection y we don't know. So like solving a linear equation, keep the unknown value one side and bring the remaining to the other side, you can get the answer. That's it, very easy question, right? Let us see the second question. If x and y are two sets such that x union y has 18 elements. So they have given in words, it has 18 elements means n of x union y. So I expressed in notation, n of x union y is 18 and they have given x has 8 elements, which means n of x is 8 and y has 15 elements, so n of y is 15. And how many elements does x intersection y have? So n of x intersection y they asked you to find out. So the same way you have to solve. So likewise the third problem is also of the same kind. They have given you in a group of people how many can speak Hindi, how many can speak English, and how many people can speak both Hindi and English. Remember, whenever you have a word both, it denotes intersection. Okay, and when you have a group of people, then it denotes union, right? Both means intersection. So third problem also I am leaving it to you. Let us move on to the fourth problem. If S and T are two sets such that S has 21 elements, T has 32 elements. Here S intersection T has 11 elements. They have given you S intersection T. They asked you to find union. Nothing different. The same relation. Previous problems we found what is intersection, so we brought all the elements to the other side, but here direct solving, directly you can find the answer. Hope you can follow. Next question. So next question, if you see x and y are two sets such that x has 40 elements, x union y has 60 elements and x intersection y has 10 elements. How many elements does y have? So they asked you to find the number of elements of the set y. So the same relation again, same relation you just find out, and we need to find n of y. So bring the remaining terms to the other side and solve it, you will get the answer. Next question, in a group of 70 people, 35 like coffee and in a group of 70 people, 37 like coffee. In a group of 70 people, so since it's coffee and tea, I used the denotation as C and T. So in a group of 70 people, C union T, I represented by 70, 37 like coffee, so N of C, 52 like tea, so N of T, and each person likes at least one of the two drinks. How many people like both coffee and tea? Both, again I told you, when you come across the word both means intersection, remember. So they asked you to find the intersection. So again the same relation, substitute the values and find what is C intersection T, right? Now let us move on to the next question. I am leaving all these problems to you. The next question is, in a group of 65 people, 40 like cricket. Here C and T denotes cricket and tennis. So since it's a group of 65 people, I have denoted N of C union T as 65. 40 like cricket and 10 like both cricket and tennis. How many like tennis only and not cricket? Number of people like tennis only and not cricket, and how many like tennis? So they have asked two questions here, right? Now listen how we can solve this problem. They didn't ask you only the number of people who like tennis, but also the number who like tennis only and not cricket. Let us solve. First we will find what is n of t, right? How will you find n of t? N of c union t, the same relation. You can substitute the values and you can find what is n of t. So here I wish to explain you how we can solve the problem using Venn diagram. So all these problems can be solved using Venn diagrams as well. So I wish to explain so that it will give you better clarity. So normally the universal set we will represent it using rectangle and the subsets by using circles. So here this circle denotes people who likes cricket, this circle denotes people who like tennis, and this is universal set, which means the entire group of people. So how many people are there? 65. So I have written 65 here. Number of n of c is 40. So this entire circle is 40, and this region intersection c intersection t is 10, and we don't know what is t, and union is 65. So how we can find this t? Diagrammatically, on seeing this, we know if we add all these 3, we should get 65. But this 40, there is a overlapping with this 10, because this 40 doesn't denote this region. This 40 doesn't denote only this region, this 40 denotes the entire of C. But this 10 is also there, right? So first you need to subtract this 10 from 40, then you will come to know only this. Yes, first subtract this 10 from this 40, so you will come to know what is this. Then from the entire group, if you subtract this, you will come to know what is T. So numerically we found using relationship, which is nothing but 35. Again, this 35 is the full of T, not only this T, not only this region. This 35 includes full of T. So full of T, and this 40 includes full of C. What does it mean? This 40 includes people who likes both cricket and tennis, and this 35 includes people who likes both cricket and tennis, because when you take it to count, the people who like tennis will fall under the 35, but they will also like cricket, right? So this 40 includes people who like both cricket and tennis. Similarly, this 35 includes people who like both cricket and tennis. But our next question is, we need to find people who like only tennis and not cricket. So what you will do, on looking at the diagram itself, we can easily identify only tennis, not cricket is this region. Only tennis, here is the overlapping, so we don't want this count, we need only this count. So how will you find this count? Subtract this 10 from this 35, from the entire 35 denotes entirety and 10 denotes this region, the intersection. So subtract this intersection region from 35, you will come to know this region. This region is nothing but only people who likes tennis. So that's what we did, 35 minus 10, which is 25, right? Hope you follow. So like this you can solve the previous problems also using Venn diagram. If you feel Venn diagram as confusing, go with the numerical by stating the formulae. If you feel the numerical is a little bit you find difficult to understand, you can draw a figure, analyze it, and then substitute the values there so that you will get a better clarity, right? Now let us move on to the last question, which is, in a committee 50 people speak French, 20 speak Spanish and 10 speak both Spanish and French. How many speak at least one of these two languages? Again, at least one of these two languages means union. You need to find union. At least one of these two languages means union. So whenever you come across these clue words, at least, union, both means intersection, don't forget. So you can solve this problem using the same relation which we used for the previous problems, right? So with this we completed exercise 1.6. I am leaving all these problems to you, so you have to complete, right? Let us move on to the miscellaneous exercise. Let us take it as a revision for the entire chapter, so that with this we will wind up the chapter and we will have a small test on this chapter. So I want everyone to practice the miscellaneous exercise, each and every problem, so that it will be a practice for the entire chapter. So if you look at the first question, decide among the following sets which sets are subsets of one another. First we starting with the concept of subset. What is meant by a subset? If all the elements of one set is available in the other set, we will call it as a subset. Now first set A they have given in which form? Set builder form. And set B, C, D they have given in which form? Roster form. Right? So always when you see the set in the set builder form, you will find difficult. So first transfer it to the roster form and then check which one is a subset of the other. So they have given x is set A is set of all x such that x belongs to R and x satisfy this quadratic equation. So in order to find the solution of this quadratic equation, we will go with the splitting the middle term. And we found, using the splitting the middle term, we found the solutions are 6 and 2. So 6 and 2 are the only two real numbers which satisfy this equation. Therefore set A has only 2 and 6. B, C, D they have given in the question itself. So from this easily you can identify. D has only the element 6, whereas A has the element 2 and 6. So D is a subset of A. And A is a subset of B, because 2 and 6 is available in the set B, where 2, 4, 6 all the three elements are available in set C. So I can say D is a subset of A is a subset of B, and B is a subset of C. This is the general relation. Separately, if you want to make out the relationship, you can. How you will say? D is a subset of A, D is a subset of B, D is even a subset of C. When you take A is a subset of B and A is a subset of C, but A is not a subset of D. When you take B is a subset of C alone, where B is not a subset of A and D because the element 4 is not available in A and D. Therefore, B is a subset of C alone. When you check out C is not a subset of any of the remaining three elements because the number of elements in C is more than the number of elements in A, B and D. Therefore, C is not a subset of A, C is not a subset of B and C is not a subset of D. Hope you understood, right? Next question is true or false only. First question let me solve, and the remaining questions hope you can do it. First question, if x belongs to A and A belongs to B, then x belongs to B. Clearly understand this is the symbol belongs to. This is not a subset. There is vast difference between subset and belongs to. If they say the set A belongs to set B, which means the entire set A is an element of the set B. If they say A is a subset of B, all the elements of A are available in B, right? I'll show you the difference. For example, let A is equals to, say, I have the element 1 and 2, right? Then if they say A is an element of B, then B will have some other elements, say 3, 4 like that, including this set A itself. This set A itself is an element of B. Hope you understood. If they say A is a subset of B, if suppose A is a subset of B, then then B will have elements like this 1, 2, 3, 4, 5. Then here the elements of A are also an element of B, therefore A will become a subset of B. Hope you understood. But here the statement is A is an element of B, which means the entire set A is an element of B. Now this is not a part of our question, so leave it. Now if x is an element of A, now our x is 1 and 2, let us say A has an element 1 and 2 and A is an element of B, which means the entire set A is an element of B, then x is an element of B. So choose one element from A. Say I am going to choose 1. Okay. Now 1 belongs to A. Now if 1 belongs to A, then that 1 also belongs to B is the statement. Is the 1 belongs to B? No. That set 1 comma 2 belongs to A, but the element 1 does not belongs to B. It may or may not. It is not necessary it should be an element of B. Right? If X belongs to A, then X should belongs to B if A is an element of B. The statement is false because 1 does not belongs to B. Immediately it may strike your mind, ma'am, you have not taken 1 as an element of B, right? So that's what I told, it is not a necessary condition. It is not necessary if 1 belongs to A that 1 should also belongs to B. It is not necessary. It may or may not. So when the general statement what they made here is, if X belongs to A, then X should belongs to B if A is an element of B. This is a general statement, so which implies it is false. This is not true always. This may or may not. So this is false, right? Similarly, you try to state true or false for the remaining subdivisions by analyzing slowly and by taking out some examples. Don't look at the general statement, then it will look vague and vague. It will look vague. So take some examples by your own for each and every set, and then analyze and then give your result whether it is true or false. If you have any doubt in that, you just ping me, right? Now we will move on to the third question. So our next question is, given that A union B is equals to A union C, A intersection B is equals to A intersection C, we need to show that the set B is equal to set C. There are three sets A, B, C. In such a way these two relations are given, and we need to prove the set B and C are equal. When we will call two sets are equal? When both the sets have the same elements, and both the sets have same elements. When do you call two sets are equivalent sets? If they have same number of elements. Equal means both the sets should have the same elements, right? Now how we can prove? This is a general statement, right? They didn't give any element. So let us assume, let us take one element in B. So our idea here is, we will take one element from the set B and we will show that this element is there in set C as well. Similarly, we will take one element, random element from set C, and we will prove that element is available in set B as well. So any element if you choose in B, it is there in C. Any element if you choose in C, it is there in B. Therefore both the sets should be equal. This is the idea behind this problem. So let us start. So let us assume X belongs to set B. If X belongs to set B, then X will belongs to A union B, right? If element is available in one set, when you are finding the union with another set, obviously that element should be present, right? So X belongs to A union B. But is given A union B is same as A union C. This is equals to A union C, which is given. Therefore, X will belongs to A union C, right? X will belong to A union C. So what does this imply? If an element is there in union, what does this imply? X belongs to A or X belongs to C. Hope you remember this keyword R. R means it can be in A or it can be in C, then it will be available in union, right? So X belongs to A or X belongs to C. Now let us take, if X belongs to C, X is already in B, right? Yes. Now X belongs to A or X belongs to C. Now if X belongs to A, imagine X belongs to A, then already X belongs to B. Therefore X will belongs to A intersection B, right? X will belong to A intersection B. But A intersection B is same as A intersection C, which is given in the question. So this implies X belongs to A intersection C, right? What does this imply? X belongs to A and X belongs to C. So this implies X belongs to A and means the element is there in the set C as well as in set A, right? Now we got the answer as X belongs to C. So we started with X belongs to A and we ended with X belongs to C. So what does this imply? B is a subset of the set C. every element in B is available in C. Now if you look at this step, we have taken this case here, X belongs to A, because R means it can be in A or it can be in C. So first case 1, we checked out if it is there in A, what will happen if it is not there in C. If it is not there in C and if it is there only in A, what happened? Even then we arrived at a conclusion that X belongs to C, therefore B is a subset of C, right? Suppose if X belongs to C, in this step itself we will get a conclusion that X belongs to B and X belongs to C, therefore B is a subset of C. Now to prove B equal to C, we need to prove the other way also. We should start with an element of C and we should end with an element of B. The same argument we can repeat. Instead of B, we can take X belongs to C. If X belongs to C, what will happen? Then X will belong to A union C. But A union C is same as A union B. Then it will imply it belongs to A or it belongs to B. If it belongs to A, then it will belong to A intersection C. The same way we can repeat the argument and we can show C is a subset of B. If both B is a subset of C and C is a subset of B, then both will become equal. So similarly we can prove C is a subset of B. So from 1 and 2 we can say that the set B is equal to set C. Hence we proved. Our next question is to show that the following 4 conditions are equivalent. First one is A is a subset of B. Second one is A minus B is empty. Third one is A union B is equals to B. Fourth one is A intersection B equal to A. What is meant by equivalent? It is not that they didn't ask you to prove whether they are equivalent sets or not. Here equivalent means the general meaning. So what we are going to prove here? Here we are going to prove that the statement 1 implies the statement 2. Similarly, statement 2 implies the statement 1. Likewise, we are going to relate A is a subset of B will imply A union B is equals to B, and A union B equal to B, then it will imply A is a subset of B. Likewise, we are going to prove all the 4 conditions, right? So let us start with the first one. So first we are going to prove first statement implies second and second implies first. So let A is a subset of B, then we need to show that A minus B is empty. Now we are going to consider the contradiction. Suppose if A minus B is not empty, then what will happen? There exists. What is the symbol? There exists. There exists X belongs to A such that X does not belongs to B. How we got this statement? Because the definition of A minus B. What is the definition of A minus B? There will exist some element in A which is not there in B, right? So there exists some X in A such that X does not belongs to B, since we have taken A minus B is not empty. But this statement won't hold good because A is a subset of B. We have assumed A is a subset of B. If A is a subset of B, every element of A should be there in B. So this is a contradiction to our assumption. So this is a contradiction. If we put like this, what does it mean? This is a contradiction. Hence, A minus B should be empty only. Therefore, statement 1 implies statement 2. If A is a subset of B, then A minus B should be empty. Now let us see the reverse. If A minus B is empty, then we need to prove A is a subset of B. If A minus B is empty, how will you prove A is a subset of B, right? Now let us assume let X belongs to A. Then if X belongs to A, clearly X belongs to B. This implies X belongs to B. Why? Because A minus B is empty. A minus B empty means what? There is no element in A which is not there in B. Because the definition of A minus B says we will leave the element common in A and B and we will write the remaining elements in A, right? Here A minus B is empty. So automatically this implies if any element in A which implies that element will also be in B. This is why, because since A minus B is empty. So if an element in A which is also there in B implies what? A is a subset of B. So this implies the second statement implies the first statement. So we proved first statement implies second statement, then second statement implies first statement. Hence the statement 1 and 2 are equivalent, right? Next we are going to prove the first statement will imply the third statement. What is our first statement? A is a subset of B. If A is a subset of B, we need to prove that A union B is equals to B. How we will prove two sets are equal? By proving that this is a subset of this and this is a proper subset of this. Therefore, two sets will become equal as we proved in the previous problem. So, let us start with A union B. Let one element belongs to A union B. The same argument we did in the previous problem. Let us assume X belongs to A union B. What does this imply? X belongs to A or X belongs to B. If X belongs to A, then what will happen? There are two cases. Either X belongs to A or X belongs to B. If X belongs to A, what will happen? Then it will imply X belongs to B. Why? Because since A is a subset of B. Since A is a subset of B, all the elements in A will be available in B. Therefore, we started with an element in A union B. We ended with saying that that particular element is available in B as well. So, therefore, A union B is a subset of B, right? Similarly, if X belongs to B, there are two cases. Either X belongs to A or X belongs to B. If X belongs to B, we will end up with this conclusion. So, both the cases are true, right? On the other hand, let us start with X belongs to B. If X belongs to B, what will happen? Then X belongs to A union B. Again the same argument. Then X belongs to A or X belongs to B. If X belongs to A, then what will happen? X belongs to A union B, right? Sorry, actually we don't need this steps at all. Here itself we can stop because we need to prove B is a subset of A union B, right? Again we are coming back to the A union B only. So if an element belongs to A, then automatically it will belongs to its union. Therefore this implies B is a subset of A union B. So from 1 and 2 we can say from 1 and 2 A union B is equals to B. So the statement 1 implies the statement 3. Now the other way we need to prove, right? In the sense we are going to assume this and we are going to prove this. So let A union B is equal to B, we need to prove that A is a subset of B. To prove that we are going to start with an element in set A, then obviously we know that element belongs to its union, but this union is same as set B which is given in the question. Therefore automatically X will belong to B. So we started with an element in A, we proved that that element also in B, therefore A is a subset of B. Hence the third statement implies first statement. So both the ways we proved, therefore one is equivalent to third statement, right? Now the last case we need to prove the statement 1 implies the statement 4 and the other way. So let us assume A is a subset of B. The arguments are similar to one after the other, right? So we need to prove A intersection B is equals to A. When we need to prove two sets are equal, how we should proceed our argument? We should prove that one set is a subset of the other and the other set is a subset of the another. Hope you are following, right? How you will prove two sets are equal? By proving that this is a subset of this and this is a subset of this, hence both will become equal, right? So we are starting an argument by taking an element in A intersection B, which implies X belongs to A and X belongs to B. No need of this argument at all, because we know intersection of two sets is always a subset of that particular set. So directly also you can write A intersection B is always a subset of A. Now the other way argument, now we are going to start with an element in A. If X belongs to A, then X belongs to B. Why? Because given in the question A is a subset of B, right? An element is there in A as well as in B, so automatically it will be there in A intersection B. Now we started with an element in A, now we ended by saying the particular element is there in the intersection as well. Therefore A is a subset of A intersection B. So A intersection B is a subset of A is a subset of A intersection B, therefore both the sets will be equal. So we proved the statement 1 implies statement 4. right? Now the other way we need to prove. Statement 4 implies statement 1. So we are going to assume A intersection B and A are equal. We need to prove A is a subset of B. So to prove this, we are going to start with an element in A, then automatically it will belong to A intersection B because both are equal. If it belongs to intersection, then by definition it belongs to A and it belongs to B. We started with an element in A and now we are saying it is also in B, therefore A is a subset of B, therefore 4 implies 1. So if you look after the arguments, everything is similar only. So where you have to start, it depends on the problem which you need to prove. Start from the proving statement. Start from the proving statement, assume an element from the proving statement and use the given statement and try to prove it. As I told you, remember this. If you want to prove two sets are equal, you need to prove one set is a proper subset of the other. Both the ways you have to prove. If both the ways are true, then automatically both the sets will become equal, right? So thus we have proved all the 4 statements are equivalent, right? If they ask you to prove equivalent, it means that you have to show that one statement implies the other statement in both the ways. In either ways it should be true, then only the statements will become equivalent, right? So do these problems as homework. Complete exercise 1.6. 1.6 is very easy. I have given you all the clues. It will take just 5 to 10 minutes to complete the exercise and do question number 2 in miscellaneous exercise. Again, it's just true or false. So I want you to complete, and after completing, recap all the subtopics in this chapter, so that in the next class we will do the remaining problems in the miscellaneous exercise, so that it will be revision for the entire chapter. You will find it easier to write your test. Okay, thank you students.